Hello everyone. So today we are going to be doing units and dimension. So under units and dimension, there are some definitions that we need to know. The first is measurement. What is measurement? Measurement is the act or process of assigning size or value to a physical quantity. I'm not going to be writing this down, so please note them. The quantities. Then we need to know the definition of quantities. Quantities are measured when we are able to quantify it by assigning value and units to such quantities or parameters. Now we have quantities are categorized into two, namely fundamental quantities and derived quantities. So I'm going to be taking it one by one. What is fundamental quantities? Fundamental quantities are the basic quantity. What do we mean by basic quantity? That means they do not depend on any other quantity. They can function on their own without depending on any other quantity. So these are the examples of fundamental quantities. We have 8 fundamental quantities. They are the length, we have time, then we have mass, we have temperature, we have electric current, we have electric charge, we have the mole, also known as amount of substance. Then we have the luminous intensity. So these are our fundamental quantities. Then now we move on to derived quantities. Derived quantities are quantities that we get by adding two or more quantities together. I mean, they depend on other quantity before they can come as a quantity. So we have derived quantities. Derived quantities are much, so we can't write everything. I'm just going to write out some and I will tell us how we derived them. So we have the velocity. Velocity does not come on its own. It was derived by, we have displacement all over the time. Displacement all over the time. Don't forget, time is a fundamental quantity. So this is how we got velocity. Displacement itself is also a derived quantity. Displacement. So displacement is also a derived quantity. Displacement is derived from length. Displacement is derived from length. So because the formula, okay, we've not gotten to units, don't worry, we'll get there. So now another derived quantity that we have is the acceleration. Our acceleration, and acceleration is derived from velocity all over time. Then another quantity that we have is the momentum, which is derived from mass times velocity. One thing you should notice is that all our derived quantity, it contains one or more fundamental quantity. That's why we call them derived. Mass is a fundamental quantity, time is a fundamental quantity. In velocity, time is a fundamental quantity. We also have force. Force is derived from mass multiplied by acceleration. So these are some of the derived quantities that we have. They are more than this. They are very, very much. We can't even finish them. So we stop here on derived quantity.
Yeah.
So we move to the units. After quantity, we have units. So we have, as we have the fundamental quantity, we also have fundamental units. Fundamental units. So our fundamental units are the units of the fundamental quantities. Don't forget we have 8 fundamental quantities. So now each of those fundamental quantities has their units. So we have length, and the unit of our length is what? Is meter. These are the fundamental units. We have time. The unit of our time, the fundamental unit of our time is seconds. We have mass. The fundamental unit of our mass is kilogram. Kilogram. Then we have temperature. The fundamental unit of our temperature is degree Kelvin. We have electric current. The fundamental unit of our electric current is ampere. We have electric charge. The fundamental unit of our electric charge is coulomb. We have our mole, that is amount of substance. Amount of substance. The fundamental unit of our mole is mole. We have luminous intensity. The fundamental unit of our luminous intensity is candela. So we move on to the derived unit. So after the fundamental unit, we have the derived unit. So derived units are also the units for our derived quantities. The derived quantities that we used was velocity, and our unit for velocity is meter per second. We have acceleration. The unit for our acceleration is meter per second square. We have the momentum. The unit is kilogram meter per second square. Then we have the force. The unit of our force is also kilogram. The unit of our force is kilogram meter. The unit of momentum is kilogram meter per second. So these are our derived units. Derived units are the units for our derived quantities, meaning our derived unit is also derived from the fundamental units. As you can see, the meter is the fundamental unit of length, kilogram is fundamental unit of mass, and kilogram is also the fundamental unit of mass. So we move on to dimension. So now we move on to dimension. Our dimension, we have 3 main dimensions. So we use these 3 main dimensions to get our other dimensions. We have M, L, T. MLT. M for kilogram, M for mass, L for length, and T for time. So now this is how we get the dimension of all our other quantities. For velocity, let's start with velocity. For velocity, if you are asked to find the dimension of velocity, so they ask you to find the dimension of velocity, first thing you are going to do, what is the unit of velocity? You must know the unit before you can be able to find the dimension. Remember that the unit of velocity is meter per second. So now we need the dimension. Meter, length is measured in meter. So our dimension is going to be L, which is for length, then our seconds, which is the time, L per T. Don't forget there is division. So the division will turn to -1. So we have L per T. This is the dimension for velocity. So if you are asked to find dimension of acceleration, our acceleration is meter per second squared. So the dimension is going to be L per T. This is raised to power -2, and there is division sign, which is going to give us L per T squared. So we are asked to find the dimension for momentum. One thing about dimension is that you must know the unit of what you are finding. So the unit of the momentum is kilogram meter per second. So our dimension is going to be kilogram is our mass, so we have m. Our meter is length, we have L. Per T our seconds, so we have per T. So this is the dimension of our momentum. So we have force. We are asked to find the dimension of force. You must always write the units first. Don't forget, we have kilogram meter per second squared. Our kilogram is measured, our kilogram is our mass, so we write m. Then our meter is our length, we write L. Then the seconds is our time, per T. This are squared, per T squared. So this is the dimension of our force. So before I forget, we need to write the dimension. All our fundamental quantities as their own dimension. All the fundamental quantities as their own dimension. So then I'm going to write out our fundamental quantities, their unit and their dimension. I'm going to write it in a tabular form. Please, you need to note this down. So we need to write out all our fundamental quantities as their own unit and their dimension. Please, you need to note this table I'm about to write. So for length, we have the unit of length is mass and the dimension is L. We have mass. The unit of mass is kilogram. The dimension is capital M. We have time. The unit of time is seconds, but the dimension is capital T. We have electric current. The unit of our electric current is ampere, but the dimension is I or A. We have temperature. The unit of our temperature is degree Kelvin, but the dimension is theta or K. We have electric charge. So the unit of our electric charge is coulomb, but the dimension is Q. Then we have our mole, amount of substance. The unit of our mole is mole, but the dimension is N. We have luminous intensity. Our intensity, the unit of intensity is candela, but the dimension is joule or coulomb. So these are our fundamental dimensions. So then that's when we are supposed to move on to derived dimension. We use each of these fundamental dimension to get our derived dimension, and we mostly use MLT. But most times, sometimes you can see all this in your question, so you need to know the dimension. Everything about these fundamental quantities is just 8, so you need to know them on your head. I mean the fundamental quantity, their units and their dimension. We're going to be using it a lot. That's the main thing in this topic. So now we have examples. Examples: we are asked to find the unit and the dimension of electrostatic force. Electrostatic force. So what is the unit of electrostatic force? You need to know some units. Okay, for us to know the unit of electrostatic force, I think we need to know the formula of electrostatic force. So what is the formula of electrostatic force? The formula of electrostatic force is F equal to K Q1 Q2 all over R squared. This is the formula of electrostatic force. So now we are going to get our unit and our dimension from this. Don't forget, K is what? K is our temperature. The Q1, Q2, they are our quantities. Q1, Q2, they are our quantities. Then the R is our distance. Now, what is the dimension? The dimension is just to say K, since K is a dimension on its own in our fundamental quantity, and Q is also the dimension of the electric charge in our fundamental quantity. So we have Q squared. Then our R is the distance, and distance is the same thing as L. So we have our R is squared, so we have L squared. Don't forget the division. You must always remember, whenever you have a division, it turns to minus L squared. So this is the dimension of electrostatic force. If you are asked to find the dimension of electrostatic force, this is the dimension of electrostatic force. So we are asked to find, another example is find the dimension of work done. Find the dimension of work done. The formula of work done is force times distance. So to find the dimension of work done, which is force times distance, don't forget our force is, okay, you need to firstly find the formula of force. Force is what? Mass times acceleration. And our mass is what? Kilogram. Our acceleration is meter per second squared. Now, these are what we are going to add into your formula. We have work done is now going to be kilogram meter per second squared multiplied by our distance, which is m. So now the dimension is going to be m, our meter, our m, it is in 2 times. So this is going to be multiplication. So we have L squared, then per t, then we have per t squared. You need to be very, very careful when doing dimension. So I think we are going to stop here. So we are going to be stopping here, and please try to attempt these questions and put your answer in the comment section. I'll be there to give you the necessary corrections. Don't forget to like, comment, and put on your notification for the next videos. Thank you.